All right, well, I'm going to just do a quick little overview of probability. Probability is a ratio comparing two things, like two sandwiches out of 15 choices at the lunchroom. However you want to look at it, you're talking about successes out of total. And so when we look at one like problem 1, you have all these 20 Fruit Loops, and 8 of them are red. The probability of drawing one that's red, there's 8 total possible reds out of a total of 20. So what is it for yellow? How many total yellows are there to pick? 5 out of 20, right? How many? Well, now we're looking at number 3 here. Now we're picking 2 Fruit Loops. Apparently we're really picky about our eating. I like to eat handfuls at a time, but you know, somebody's picking them out one at a time. Of these 20, what are the chances of getting the first one to be red? But sure, 8 out of 20, and that's fine. You can simplify it. But then, and it says followed by, the red is eaten after it's selected. Now, what's the total before we draw a yellow? What's the total now after we've eaten a red? There's only 19. So then it's going to be how many yellows are there? 5. So if you want to multiply those out, you can get 40 out of, what is that, 380? You can simplify that, but you get the idea. Then if we do 3 of them, we're picking a red, which is 8 out of 20. Then we're picking a yellow, which was 5 out of 19. Then we're going to pick a green, which is what? 7 out of 18. And you don't have to multiply those out. But do you know how to in your calculator? Do you know the best thing on your calculator? If you haven't seen this on your calculator, I want to show you right now. For some reason, this isn't. So a neat way to multiply with the calculator is just go 8 divided by 20 times 5 divided by 19 times 7 divided by 18. And we're trying to be efficient here. We're trying not to make you do a bunch of busy work. Wouldn't it be nice if the calculator simplified that for you? Because this isn't a super helpful answer, is it? But what if you go, what's that duck that sells insurance? What's that called? Oh, Aflac. So would you say with me, math, frac. Together, math, frac. Number 1, and there you go, 7 out of 171. Isn't that nice? That's such a helpful thing. How many of you have never seen that feature before? Yeah, it's great. Okay, so that is probability. Let's talk about distance formula. So if I have a number line and I want to go from 8 to 10, how far is that apart? 8 and 10. 2, right? So what we do is we take 10, or x2, minus x1. Do you agree that's how you find the distance on a line? What if I pulled a fast one here and I squared this, and then I took the square root of this? Why would I do such a thing? Hatred? No. Yeah. You're close. That's right. That'll make it positive for you. So let's say I went 10 minus 8, I'd get 2. 2 squared is 4. Square root of 4 is 2. There's your distance of 2. But what if I went 8 minus 10? Now I get negative 2. But what happens when I square negative 2? Get a 4, and the square root is 2. So either way, I get a distance of 2. Isn't that slick? But here's an even better way. Why not, if I go from 8 to 10, and then perpendicular, I'm going to go 6 to 9. So how far is it from 8 to 10? 2. And how far is it from 6 to 9? 3. So we can't just add 2 and 3 because they're perpendicular to each other. But do you remember how you would find this distance? Pythagorean theorem, which says that if you made a square of this one and made a square of this one, it would add up to this square. Right behind your head here is a student made this for water. It leaks, unfortunately, but you can really see Pythagorean theorem really well. Is that here's your little right triangle here. This is one leg makes a square. This leg makes a square. And the hypotenuse, the diagonal, makes a larger square. She made this, and she put red dye in these two, and then when you turned it this way, it drained in and completely filled this perfectly. That's Pythagorean theorem. A squared plus b squared equals c squared. Isn't that neat? So that's very old. The Babylonians figured it out independently from the Chinese, who figured it out from the Ecuadorians. All over the world figured this thing out, is that if you took this x2 minus x1 and squared it, and then you added it to y2 minus y1 and squared it, you're going to take the square root of that to get the distance. That's Pythagorean theorem. You agree with that? Now wait a minute. I see a pattern. What pattern do you see when we go from one dimension to two dimensions? What are we doing? Turn to your neighbor real quick. Tell them what pattern you see going from here to here. Aren't you just adding the difference and taking the square root? Do you have any guess of what this 3D would be if we use Z2 and Z1? Take a wild guess. X2 minus X1 squared, yeah? Plus what? Y2 minus Y1 squared. You are correct. Now imagine that you took that diagonal and then you pulled that out perpendicular. Now the diagonal becomes a leg, and this straight out becomes a leg. You get another right triangle, don't you? And so why not square that and then add Z2 minus Z1 squared, and now you've got 3D distance. I want to go for 4. Let's go for 4. W we'll use for this one. So this is going to be the square root of, what do you think? What do you think? X2 minus X1 squared plus Y2 minus Y1 squared plus Z2 minus Z1 squared plus W2 minus W1 squared. No kidding, you could go as far as you want. They think that the universe might be either 9, 10, or 11 dimensions. 9, 10, or 11 of these to find the distance between 2 points. Pretty cool. It all comes from perpendiculars. So these 2 points change in x squared. If we go perpendicular, now it's the change in y squared to get this diagonal. If we pull this out of the page, perpendicular, now this diagonal is perpendicular to that, we can find that distance. And you just keep going perpendicular, you can keep adding those up. That's the distance formula. Last one, midpoint formula. Midpoint formula is just as easy. You've got 4, 6, 9, 8. This point down here would be, what would this point here be? How far over would it be? If this is 4, 6, and this is 9, 8, what would this point be? Over 9, up 6. Good. So what is the middle between 6 and 6? 0, right? But what's the middle between 9 and 4? Well, it's 9 plus 4 divided by 2, or 13 halves. Not pretty, but it'll work. What's the middle between 6 and 8? What's the middle between 6 and 8? 6 plus 8 over 2, which is 7. Yeah. So the midpoint for this one is going to be 13 halves comma 7 is the midpoint. Okay? So all you're doing is you're going x1 plus x, or y, blah, blah, blah. x1, give me just a second, x1 plus y1 over 2. God, I got it wrong again. x1 plus x2 over 2, y1 plus y2 over 2, and just keep going for dimensions. Your homework is some probability, midpoint, and distance. That's it for tomorrow. We'll have that quiz tomorrow too, and Puzzle Friday.